Hello folks, welcome to Math and Physics for You. Today we will do instantaneous velocity if we are given a position vector of an object in space. As you saw in the previous video, we found the average velocity. Now we want to find the instantaneous velocity. Now what's instantaneous velocity? Instantaneous velocity is similar to the average velocity, but it's the velocity at the instant that you want it. It's in this case, if we look at the formula that we have used to find the average velocity, it was like this. V average equals to RT plus delta T minus RT divided by delta T. It's the final position vector minus the initial position vector over the change in time. But if we are talking about instantaneous velocity, this change in time is so small, it's almost zero, which means that the 2 points here, RT plus delta T. But if the change in time is so small, means point B becomes so close to point A, it approaches point A. Let's say at time t equals 1 and times equals 1 plus 0.00001. It's so small, so the 2 points becomes almost 1 point. So at that instant, we say the velocity now is at that instant. Let's say t equals 1 as in this example. So we write it this time. It's the limit of the same expression we used before, but this time we say as delta t approaches 0. That is, the change in time is almost 0. And this is now written as dr over dt. Is the differentials, the derivative of the position vector r with respect to t. So this expression gives you the instantaneous velocity. So remember now, instantaneous velocity is the derivative of the position vector with respect to t, with respect to time. Is the derivative, or we say we differentiate, because d is for like differential, a small change in time. So let's take an example. So this diagram here, we saw that how if delta t is so small, point B gets closer. It's like C is so close to A because delta t is smaller. And then if we keep reducing delta t, we get almost 1 point A. That gives you the instantaneous position and instantaneous velocity. So we have an example here. RT is the position vector of an object at time t. Is given by this equation. And we want to apply the formula to find the instantaneous velocity at t equal 1 second. So straightforward, we say by applying the formula, Vt, the instantaneous velocity, equals to the derivative of r with respect to t. So it's the derivative of this equation. We know how to derive this equation. So it's with respect to t. So we multiply 2 times the power, 2 times 3. So you get here 2 times 3. Now we take 1 from the power, 3 minus 1, so you got t square. So 2 times 3, t square I, plus the same thing here, 3, the constant, times the power, 3 times 2 will give you 6. Subtract 1 from the power, so t, 2 minus 1 is t. Tj minus the derivative of a constant is always 0 because it doesn't change. It stays the same, so the rate of the change is 0. So that's why we have 0k, so there is nothing here. Okay, simplify. So Vt, instantaneous velocity, equals 6 t square I plus 6 t j, right? So we need to put here, what do we have to put? t. So thank you for reminding me. Okay, so we sub the value of t equals 1 v1 c 6 times 1 square plus 6 times 1. And anyway, this doesn't change the result. Very good. So by simplifying, that gives you v equals 6i plus 6j. So this is the instantaneous velocity vector. But we can go further to find the magnitude, which gives you the speed. So we say the absolute value equals to root x square plus y square plus z square if we have z, but here we don't have z, so we have 6 square plus 6 square. If we solve this, we get the answer 8.46 meter per second. And to have full picture, normally we need to give the direction of the vector. So to find the direction, the angle theta, we have like x and y directions. This is 6i in the x direction, 6j in the y direction. So the angle theta will be equals to tan inverse y over x. And we sub 6 and 6 for y and x, and that gives you tan inverse of 1, which is 45 degrees, or pi over 4. So this is the direction of the instantaneous velocity vector. And there you have it, folks. Thank you for watching. Please subscribe.